A very warm greetings to all my dear students. In the previous video, we have discussed about decimation frequency, fast Fourier transform general structure. In this video, we are going to solve on simple problem based on DIF FFT butterfly flow graph. Okay, we'll see what is given in your question, right? So your question is x of n is equal to n plus 1, n is equal to 8. 8 means 8-point DFT. You have to perform 8-point DFT. So you know radix 2, right? N is equal to 8. It can be written as 2 power 3. So 3 mentions the number of stages and 2 mentions your radix. Okay. So here you will have 3 stages. You have to find x of k using DIF FFT algorithm. In DIF FFT butterfly flow graph, your first stage will be 8-point DFT. And your second stage will be 4-point DFT, which means here you will have 2 4-point DFT, and your third stage will be 2-point DFT. Here you will have 4 2-point DFT. Okay. So what is given? N plus 1. So you have to find out the sequence of x of n. So you know the limit for n, which varies from 0 to n minus 1. Here you have to perform 8 points. So n is equal to 8. So 8 minus 1 is 7. So the limit for n varies from 0 to 7. So when you substitute 0 here, x of 0 will be 1. So this is x of 0. When you substitute 1 here, you will get 2. When you substitute 2, you will get 3. When it is 3, 3 plus 1 is 4. You will get x of 3 as 4. Next is x of 4, it is 5. X of 5, it is 6. X of 6, it is 7. X of 7, it is 8. So here you are given with the sequence for x of n. This is your input. So your input should be in natural order and your output will be in bit reversed order. Okay. So here it is your first stage, which is your 8-point DFT. So you are dividing the stage sequence into 2 halves. In the second half, you will have the twiddle factor multiplication along with the minus 1 factor. Okay, which I have already discussed in the previous video. You can go through it. Okay. So in the second half, the last 4 sequence we have the multiplication and minus 1 factor. So this is your butterfly sequence. In the sequence, first half will be your butterfly sequence. Okay. So we find out the value of x of 0. It is 1. So first input is 1. From here we are taking the second input. Directly we are taking. So no multiplication. 1 plus 5, 6. The second sequence, first input is 2 and second input we are taking from here, it is 6. So 2 plus 6, it is 8. Third one, 3 plus 7, it is 10. Fourth one, 4 plus, from here it is 8. So 4 plus 8, 12. In the second half, you will have the multiplication value. If you miss it, your output will be totally wrong. Okay, so first input is 5. 5 into minus 1 into 1. It will give you minus 5. The second input comes from here, plus 1. It is minus 4. For the second one, your twiddle factor value is real and imaginary part. So you have to multiply the term with this whole term. So 6 into minus 1, it is minus 6 into this one. 0.707 minus j 0.707 plus the second input comes from here 2 into the twiddle factor value. Okay. So here I have simplified for x of 5. X of 5 is equal to, I have multiplied this one and your answer is minus 2.828 plus j 2.828. Okay. So this can be taken for the next stage. And next one, your first input is 7 into minus 1 into minus j will give you plus j. So 7 into plus j, 7j minus, the next input comes from here, 3 into minus j. So gives you minus 3j. Your answer is 4j. Next one, 8 into minus 1 into the twiddle factor value. And the next input comes from here, 4 into the twiddle factor value. And answer for x of 7 is, I have solved it here. Your answer is 2.828 plus j 2.828. That's it. Your first stage is over now. And second stage you will have, this is first 4-point DFT and this is second 4-point DFT. Okay. So here in this first 4-point DFT you are dividing the sequence into two halves. In the second half you will have the multiplication factor and along with the -1 value. So your first input is 6, the second input comes from here, it is 10, so totally 16. For the second sequence 8 plus 12, it is 20, and the third sequence 10 into -1 into 1 gives you -10 plus 6. Okay, so your answer is -4. The next one 12 into -1 into -j gives you plus 12j, and second one 8 into -j gives you -8j. Your answer is 4j. For the second DFT, again you are dividing the sequence into two halves. The second half you will have the multiplication factor. So first input is -4. So second input comes from here plus 4j. For the second one, you have to consider the answer value. This one, okay. The second input comes from here. Again, you have to consider this one. So when you simplify, you will get j 5.656. For the third line, you will have -4, 4j -1 into 1 -4. Here the second input comes from here, -4 into +1 -4j. For this next sequence, you have the answer here, 2.828 plus j 2.828 into -1 into -j. So it gives you plus j. The second sequence comes from here, the answer into -j. Okay, so I have simplified this one. Your answer is j 5.656. So this is your second stage of your DIF FFT, and your third stage, so it has 4 2-point DFT. Okay, so in the first 2-point DFT you will have 16 plus 20 is 36. Second one 16 minus, you have -1, so 20 into -1 -20, so your answer is -4. And the second 2-point DFT, your first input is -4 and the second one comes from here, it is plus 4j, so your answer is this. The second one -4 into 1, 4j into -1, you will have -4 -4j. For the third 2-point DFT, you will have -4 plus 4j plus, so your answer is j 5.656. I have written it here and simplified it. For the second one, you will have first input j 5.656 into -1 into 1. The second input -4 plus 4j. So I have simplified it. Your answer is this one. For the fourth 2-point DFT, your first input is -4 -4j, and the second input comes from here j 5.656, and I have simplified it. I have got this one. For the second line, your first input is -4 -4j. The next one, you have the multiplication factor -1, so -j 5.656. So your answer is this one. That's it. So please do remember, your output will be in bit reversed order. Okay. So first one will be x of 0, second one will be x of 4, third one is x of 2, and next one is x of 6, x of 1, x of 5, x of 3, x of 7. Okay. So your final output x of k is equal to, this is x of 0 36, and this is x of 1, you will have here -4 plus j 9.656. Next one is x of 2, you will have here -4 plus 4j. This is x of 3, your answer is -4 plus j 1.656. Next is x of 4, from here I have taken -4. Next is x of 5, you will have here -4 minus j 1.656. Next is x of 6, is here -4 minus 4j. Next is x of 7, -4 minus j 9.656. That's it. This is your output sequence, and you can verify your output by checking the 3 statements. Okay, I'll tell you what is that. So your x of 1 will be complex conjugate of x of 7. You can verify it. Here you will have -4 plus j 9. Here you will have -4 minus j 9. And the next statement, x of 2 will be complex conjugate to x of 6. Here you will have -4 plus 4j. Here you will have -4 minus 4j. So both are complex conjugate. The next one, x of 3 will be complex conjugate to x of 5 -4 plus j1. Here you will have -4 minus j1. That's it. By verifying these three statements, you can verify your output whether you have done it in a correct manner or not. Okay. So I hope you have gotten clear idea about how to solve this DIF FFT butterfly flow graph. Yes. Thank you. See you in the next video. So for your better understanding purpose, I am showing you this one. You can refer it. This is your first stage. This is second one. This is your third stage and your output.